All right, so for today, we are going to start learning about word problems that we are going to use either substitution or elimination for. So today, all we're going to do is we're going to read through each of the word problems and we're going to determine what the equation should look like. We're not going to solve for X and Y today. We're just going to determine what the equation should look like. So you can see on our notes page that there are 3 different types that we're going to look at. So let's first start with this first type. Let me get to where I can. There we go. All right, so in this first type, we can see that we want to read through the equation. And we know that this is going to be where there's going to be $2 totals. And our first equation is going to be something X plus something Y equals the dollar amount. And equation 2 is something X plus something Y equals the dollar amount. So we read through the whole problem first, then we go back and determine what we need to do. So Carrie and Martha went shopping for their pets at the local pet store. Cat toys and dog bones were on sale. Carrie bought a toy for her cat and 3 bones for her dog. She spent $8.42. Martha bought 2 toys for her cat and a bone for her dog. She spent $7.09. What are the sale prices for the cat toys and the dog bones? So we know we want to know what cat toys and dog bones are. So we need to first identify our variables. And it's really important that you do this because if you don't tell me what your variables mean, then we aren't able to decide if you got the answer right or not. Okay, so typically you're going to do it in the same order that it comes through in the word problem. So here we can see cat toys, then dog bones is pretty common. So we're going to do X is cat toys. And we'll do Y is dog bones. So now I've identified my variables. Next, I need to look at the equation or look at the word problem and figure out what I want to do for my 2 equations. So I know I have 2 different people. I have Carrie and Martha. So that's going to be my 2 equations. So Carrie and Martha. So for Carrie, we're going to insert our equation. Let's see. Carrie bought what? Carrie bought a cat toy for her cat and 3 bones for her dog. So I know cat toys are X and dog bones are Y. So if she bought a single cat toy, then that's just X. And then she also bought, so that's plus 3 dog bones, so that's 3Y. And she spent a total, which is equal, of $8.42. So see how that just reads the same way that it read in the problem, right? So if we were to read just the equation part, it would read Carrie bought 1 cat toy, right? Because I know cat toys are X, and 3 dog bones, because I know dog bones are Y, and she spent $8.42. So that's not so bad, right? So let's do it again for Martha. So for Martha, let's see what she bought. Martha bought 2 toys for her cat. So that's 2X, right? Because X is cat toys. And a bone for her dog. So that's 1 of those. That's just Y. Equals, how much did she spend? She spent $7.09. Beautiful. So now when we look at this equation, what we can see is that it is the setup in the same way that we've been doing our elimination problems, right? So from here, we would look at this as an elimination problem to be able to solve for X and Y. We're not going to do that today, but you know, right, that we would have to find the least common multiple and then eliminate one of the variables to solve for the other one. All right. So let's look at the second one. I want you to try the second one on your own first, and then we will do it together. So go ahead and pause the video and see what you can do. All right, great job. So now we want to do the same thing we did before. First, we're going to, why am I in like super bold? What is happening? See, this is what happens sometimes, right? We do our very best and then it doesn't do what we tell it to do. All right, so we want to define our variables first. So we are going to say x is what? Well, we got to read the equation first, right? We have no way to know what x is. So Rose and Leticia go shopping. They find a huge sale on sweaters and purses. Rose buys 1 sweater and 2 purses, spending $32, and Leticia buys 3 sweaters and 1 purse, spending $46. What is the price of the sweaters and the purses? All right, fair enough. So I know I want to figure out what the sweaters and purses are. So x equals sweaters, right? And that means that y is going to equal what? Y equals purses. Perfect. All right, so again, we have 2 people. So we're going to do Rose and Leticia. Perfect. So now we're going to go back to Rose and we're going to say, okay, so what is Rose's equation? What did Rose buy, right? So Rose buys 1 sweater. So we know that's 1x or just x. And so that's plus 2 purses. So 2y because y is purses. And she spent, so equals $32. There it is. Perfect. Now Leticia, right? We got to figure out what she bought. So she bought, says Leticia buys 3 sweaters. So that's 3x. And so plus 1 purse, so just y. And yes, you could do 1y, but you don't need to, right? We just know the 1 is implied. And she spent $46. Beautiful. So here again, we need to do both of those. I thought I had them both highlighted. So here again, we have this in our elimination format, right? Where we have the 2 equations written in standard form. And now we would have to find what? You know, even with this one, we wouldn't have to do the least common multiple. We could just multiply by -2 on both sides, right? So that we could cancel out the x's. Or we could do the bottom and multiply by -3 on both sides if we wanted to, and that would get rid of the y's and we'd solve for x. So on the bottom, right? So between Rose and Leticia, same thing. So I have 2 positives here, positive x and a positive 3x. So we know we're going to have to change the sign. And to get rid of the x's, we would need to then multiply by a -3 on this whole equation. Or we could come down here and multiply by a -2, right? Because we want to get those lined up so that they can be eliminated. All right. So again, we're not going to solve today, but that is how you would solve, okay? All right, so let's go ahead and move on to type 2. So for type 2, this is going to have one that has a dollar amount in the total and one that has a number in the total. So you can see here something x plus something y equals a dollar amount. And then in the number equation, something plus something equals the number. Okay, so let's see what that means. So we read through the equation first. So the concession stand is selling hot dogs and hamburgers during a game. At halftime, they had sold a total of 78 hot dogs and hamburgers combined, bringing in a total of $105.50. How many of each item did they sell if hamburgers sold for $1.50 each and hot dogs sold for $1.25? All right, so the easiest way to do this is to first identify our variables. So let's do that first. So what are we going to make x? I would say just reading from the start, it has hot dogs and then hamburgers. So I would say hot dogs is x. And I would say hamburgers is y. So y equals hamburgers. All right. So now we want our dollar equation. And what is that going to look like? So our dollar equation is going to have something x plus something y equals the dollar amount. So if we look here, we know we're dealing with money. So we're going to need to deal with money here. And so we can see how many of each item did they sell if hamburgers sold for $1.50 and hot dogs sold for $1.25. And so that's what we want to use, right? So $1.25 of hot dogs, right? So that's X plus $1.50 for hamburgers, Y, equals, pardon me, equals the total amount that was brought in, right? Or the total amount of money that was made, which was $105.50. Perfect. So there is our money equation. Now we have the number equation, right? So when we look at the number equation, we can see there's only one other number in here, 78. So how do I know what I'm going to do for X and Y? Well, it's just as simple as X, as X plus Y equals whatever that total is. And in this case, the total is 78. And all that's saying is that I have X number of hot dogs and X number and Y number of hamburgers. And so when I add those two together, the total amount that we sold was 78. Okay, perfect. All right. So there again, we have it in our elimination format, right? Okay, so now we are going to have you try number 4 on your own. So go ahead and pause the video, see if you can figure it out, and then come on back. All right, well, hopefully you were able to get that one. I know these are a little bit trickier, but of course, first we want to define our variables, right? So hopefully you did that first. So a concert advertised the following ticket prices. Adults are $9, children are $5. A group of 20 people went to the concert and paid $148 for their tickets. How many adults and how many children were in the group? So first we define our variables. So X equals what? Yep, adults. And now we have Y equals what? Yep, Y equals children. Very good. All right, so now we want to do our cost equation. And what does that cost equation look like? So we have X, which is adults, and how much is the adults? So $9 X, right? Plus however many children's tickets. So that's $5 Y equals the total amount that they spent for a total of $148. Great job. All right, and then finally, we want to do our number equation. So in this case, we have, same before, right? X plus Y, the number of adults plus the number, plus the number of children equals the number of tickets that were sold. So 20 people in the group, so they bought 20 tickets. Perfect. Great job. All right, the last one is going to be the hardest, but I don't want you to panic, okay? Because I'm going to explain it first. Let me, oh, you know what? I moved that where it doesn't need to go. It needs to stay here. Okay, so the first thing you need to understand is what is break even. So break even is when you are running a business and you're trying to figure out how much you need to sell in order to break even, right? In order to get to zero, to where you aren't having any losses and you're not making any profit, you've just broken even. And so, for example, let's say I wanted to buy a shirt and I decided that I was going to raise the money by selling cookies. I buy the ingredients to make my cookies and the ingredients cost me $5 total, okay? And I'm going to sell the cookies for $1 a piece. So how many cookies would I need to sell to make back my $5? 5 cookies, right? Perfect. Yep. So if I sell 5 cookies, I'll at least not have lost any money. And that's the goal. Okay. There's also something called a fixed variable or a fixed cost. And what that is so what that is when it doesn't matter how many cookies I sell, the number doesn't change. So for example, let's say that I printed flyers and I was advertising with those flyers and I spent $1 on those flyers. Well, now my cost is the amount that I bought for the cookies, right? The $5 plus the $1 for advertising. So now we add those together, and how much do I have now for, I'm sorry, how many cookies do I have to sell to make back the $6 now? If they're $1 a piece, now I have to make $6, or I have to sell 6 cookies in order to make that money back. But that doesn't matter if I sell 1,000,000 cookies, I still only spent $1 on the advertising or on printing those flyers. So that is a fixed cost. Okay. All right. If you're still struggling with that, don't worry. Go ahead and email me. I'm happy to walk you through how that actually works. Okay. All right, so looking here, we have our cost equation and we're going to have a revenue equation. So remember, revenue is when we sell something and we bring in a profit or we bring in money, right? So revenue is going to be a little bit different. So cost is like any fixed cost. That's what this one is, right? Right here is going to go where our fixed cost is, and also any variable cost. So a variable cost is like if I have to purchase material to be able to make an item, then the cost of the material is part of the cost, but it's going to change depending on how many I make, right? Because if I only make one, you're going to see here in a minute, there's material for a hat. If I only make one hat, then it's only going to cost me this $5.50. But if I make 2 hats, I have to buy the material for 2 hats. That's going to cost me $11. So the more I make, the more I have to purchase, right? So my costs increase per item. Same thing with revenue, right? The more I sell, the more revenue I make. So that's variable. It's going to change depending on the number that I sell. Okay. All right. So let's read the question. It says, you just bought a coffee shop for $153,600. Now, is the cost of the coffee shop going to change depending on the number of cups of coffee that I sell? It won't, right? No matter if I sell 1,000,000 cups of coffee or none, I still have to pay exactly $53,600 in order to purchase the coffee shop. So that is a fixed cost. The prior owner had an annual monthly revenue of $8,600 and an average monthly cost of $5,400. So these, we're saying the average, which means that these are going to increase or decrease, right, depending on the number of months. So in this case, if I were to have 2 months of revenue, then this number would go up, right? If I were to have 2 months of cost, then this number would go up. So that makes that the variable. So month is my variable. All right, if your monthly costs and revenues remain the same, how long will it take you to break even? So we know that we're trying to figure out how many months it would take me to break even, because that is the way that these numbers are shown. Okay, so first I define my variable, and in this case I only need to define X because Y is what we're trying to figure out. Okay, so X is months. And now we're going to do our cost equation. And we're just looking for the things that are costing us money first. So cost equation. We start with our fixed cost. And remember, we talked about our fixed cost is the coffee shop itself. So that is $153,600 plus whatever our variable cost is. So what cost do we incur every single month? And on average, right, we have $5,400 per month. So that's where we get that variable, or that X, okay, equals Y. That's what we're trying to figure out. Now we have our revenue equation. All right, our revenue equation. So here, all we're looking for is the revenue itself. And in this case, you're not going to have any fixed revenue, right? Nobody's paying you every single month just to exist. So we only have variable revenue. So we look here and we see that on average, our monthly revenue is $8,600. So that's what we're going to put here is $8,600 per month. That's what that X is, equals Y. Now, when we look at this, look here, we have a number plus a variable equals Y, and we have a variable equals Y. And so this is going to be our substitution method, right? And we'll be able to substitute this Y for this equation. So by setting our cost equation equal to our revenue equation, we're going to be able to figure out exactly how many months it's going to take for us to be able to break even or make our money back, right? All right, try number 6 on your own. So go ahead and pause the video and then we'll do it together. All right, great job. So let's first read it, right? It says a fashion designer makes and sells hats. The material for each hat costs $5.50. The hats sell for $12.50 each. The designer spends $1,400 on advertising. How many hats must the designer sell to break even? So because we want to know how many hats it's going to take to break even, we know that X equals hats. So that's how we define our variable. So now we're going to start with our cost equation, right? And our cost equation is going to be our fixed cost. So which one of these is our fixed cost? Which one is going to stay the same regardless of the number of hats that we sell? Yep, the 1,400. 1,400. So that advertising, it doesn't matter if I sell 1,000,000 hats, the advertising still only costs me $1,400. Plus, what are my variable costs? Right? Remember, this is the cost. This is how much I have to spend in order to make a hat. So, yep, the material for the hat is $5.50 per hat. So we say $5.50 X, right? Or $5.50 per hat equals Y. And finally, we need to do our revenue equation. So for our revenue equation, we're looking at just the money that we're bringing in, right? So that is how much are we selling those hats for? If I sell 2, 3, 5, 20, 100 hats, the price is going to continue to increase. Not the price per hat, but the total revenue or the total money that we're bringing in is what is increasing, and that's what makes it variable. So $12.50 is what we're selling each of the hats for. So the revenue is going to be the amount that we're selling the hats for times the number of hats that we're selling equals Y. All right, so there again, this puts this in substitution method, and we will set the cost equation equal to the revenue equation by substituting this 1250x in for Y. Perfect. All right, so your homework for this assignment is to go through and determine which one of the 3 types of equations you're going to write for each of these problems, and then actually write out the equation just like we did. Define your variables and write out your equations. So you just have 8 of them to do there. It won't take you very long, and then go ahead and submit that via Google Classroom. All right. And we will be putting that in for a grade. So make sure you get that turned in. All right. Thanks, guys.